G'day everyone and welcome back to my channel. I just want to say sorry about the last video ending abruptly. I noticed it got to about 45 minutes or so and I thought, man, it's getting on, I should end it there. And I'm just going to admit this, I haven't put the video merging software on my computer. It's only on my phone and it takes like an hour and a half to 2 hours depending on the length of the video, sometimes even more, to merge all the segments together into one format. And just to add a 2-minute ending onto a 45-minute video would have taken like 2 hours. So I just uploaded it. I'm going to put the software on my computer so that won't happen again. The other thing I noticed in the last two videos, excuse me, I got the hiccups, just give me 1 second. Excuse me. The other thing I noticed was not the aspect ratio, the orientation of my videos. Something happened last time, and I think I know what it was. It's because I went to grab the phone to take a few shots of different things, and I must have had the auto rotate on and the screen flipped. So I'll be conscious to not let that happen again. Anyways, there's a few things I want to point out here. One, there's no insulators around the pins, in between the pins and the anodized heatsink. Yes, it's anodized, black, but seriously, no insulation? Come on. Anyways, I've got the parts for that. So we'll put insulating spacers on all 8 pins. This is the base connection. Like I said, there's no base resistors, so we'll take this link out, put one of these on each base pin, commoned up to the base wire. Same for both sides. And a little bit of heat shrink. So without any further ado, let's get on to it. Brilliant. Just get rid of as much of that nasty solder as I can get rid of. No, I didn't just cut the pin shorter, I just cut a little bit of solder off of it. I have to change my soldering sponge soon. Good enough for Australia, as they say. No, it's got to be good enough for me. I'm thinking put the resistors to a midpoint like that, but I don't want them to short out on the collector or the emitter. I think those might be the emitters actually, I'm not sure. Yeah, they're the emitters. Yeah, duh. Anyway, gotta get them in there somehow. I'm just trying to think. Alright, what I'll do is I'll make up little loop-de-loops. Well, that was wonderful. I'll go grab another one of those. There's still a bit of leg on that resistor, so I can still use it for something. Not that resistors are exactly expensive by any means, but the thing is with components, it's not always the cost, it's when you need it now and you don't have it, if that makes sense, that it becomes a problem. So it doesn't really matter if the thing's only worth a couple of cents. If you go waste all your components, even if they're cheap, well, you won't have them, will you? I'm thinking something like that. And then, insulators. I'm sure I have them. I do, I'm just not sure if these are going to fit the pins. They're ceramic too. Let's see. These are ceramic. You can hear it. Let's see if they fit the pins. There's a bit of solder over the end, that's why it's hard to slide it on, but they appear to fit. I just don't know if they're too long. Yeah, just break it. Ah, man. How bloody annoying. You know, they're too long. That's the problem. I guess I could put heat shrink in there. Actually, you know what I got? I know exactly what to do. I know exactly what to do. Not heat shrink, but spaghetti tubing. Just need to cut up little pieces of spaghetti tubing. Don't know where that went. Make sure I hold them all. Alright. So, take these other wires off as well. It doesn't matter which way the two yellow wires go, they're just the emitters. The emitters both get tied together via the emitter resistors, obviously, so that does not matter, but it's obvious anyway, just from the length of them, where they were anyway, even if it did matter. Spaghetti tubing. And there's still a little bit of ceramic in this one. It's out of the way. There's still a little bit of ceramic in there, but obviously that's not a problem. That's not going to short, it's an insulator. It's just fallen down all the way into like the back of the transistor, if that makes sense. Well, at least now there's some insulation on the pins. I tell you what, I'm glad that I went over this thing the way I did and didn't just, you know, chuck a couple of New Zenas in it and whatnot and use it the way it was, because there was so much wrong that I've discovered little bit by little bit going over it. You know, it's just, and so much room for improvement. And you know, like by doing all these little things, it's going to make it a lot more solid, you know, like it won't go into oscillation ever again, all that sort of good stuff, you know, like it'll be way more reliable. It will last me a long, long time. See, that's the thing about me, I don't mind spending quite a few days or hours or whatever on something if it's going to serve me for, you know, the rest of my life, literally. That's why I like older stuff like this, because as you can see, it doesn't matter if it's completely toasted, you can fix it. Like where that circuit board's all carbonised, if that gets worse in the future to the point that it's actually conductive, for example, I could literally just cut that piece of board out and replace it with a piece I make up myself. Alright, I thought the transistor pin was spinning. I got worried for a second. That's why I was moving that resistor around. I was just trying to see if it was the actual transistor pin spinning around or if it was just the resistor leg bending. Thank God it was just the resistor leg bending. Yep, I'm happy with that. Alright, so I guess I want to make my resistors sort of go out. I thought I'd save you guys the time of watching me unscrew all this crap, because I had to take the base out and slide it to the side to actually gain access to some of the screws. So I just pulled it all apart in my own time, and I'll just make up one of these, you know, and then I'll go off and do the other one in my own time. And then we'll come and sort out the pot situation, which those pots are definitely going in. I might have to change some resistor values, but from what I've been able to trace out so far, it doesn't look like I'm going to need to change anything at all. So that's good. I'm just wondering if I should try and insulate that. I think that's actually going to be quite solid. It's not like the resistors can really go anywhere, because they're like on an arch like that. They can't bend in, they can't go out any further really. They're 1 watt resistors with thick ass leads. They're not going to just, like, you know, bend. I mean, look at how it was in the first place. There was no insulators there or anything at all. So I mean, I think what I've done is already better. Well, that's one side done. Yeah, I'm not going to even touch that. That's good exactly how it is. I'm happy with that. Yeah. Alright, well, I'll go do the other side up in my own time, because I don't want to bore you guys. But wait, what? I didn't do that. Oh, I did. I was tripping balls for a second. I thought that the link between the two base pins was already missing, and like it was just being driven one transistor. I was like, wait, what? I just woke up. It's early in the morning. Oh goodness. Alright, so I'll go off and finish this now, and then I'll come back and we'll sort out the pots. I'll upload that video, and then we'll do some calibration on it. And then after the calibration, we're going to go take basically a few different loads, like some switching power supplies that I've built, like boost converters, flyback converters. We might pulse, like, you know, like just touch random inductor values, shorting the output to create back spikes and stuff like that. You know, just abuse it, short it, do all sorts of stuff to it to test it and see how it takes it, you know. And obviously have the scope hooked up to various places and see what's going on under said circumstances. So I think actually we really do only have 2 videos left. This video, I guess I'll just do the pots and the VE meter, whatever you want to call them, panel meter, calibration, all in this video, because the calibration only takes a couple of seconds. The pot's only going to take a couple of seconds. This only take a couple of seconds. So I'll do all this in one video, and then we'll do the compensation, looking at the op amps, all that good stuff, response, noise and ripple, in the last video. So 2 more videos, that's including this one. I'll be back soon, guys. Alright, so that's the modification with the base resistors and the insulators done to both heat sinks, or all 4 output transistors now. So now I'm going to sort these out. I literally just have to trace out a couple of resistors, do some calculations on current that's sourceable to the pot. Hold on, my cat's in the box wire again. Get out of there, please. Out. Sorry. Let me out at you, make you feel bad for yelling at them. Anyways, most likely, well, I'm going to be coming back in a minute for you guys, but most likely we'll be back in a minute and be putting these 2 pots in, and yeah, I'll upload the video, and then what was the other one thing I was going to do? Calibrate the VE meter things, panel display meters, you know what I'm trying to say. So we'll come back, put them in, come back again, calibrate the displays, and then I'll upload that video, and then I'll upload the last video. Alright, I'll be back soon. Just something I meant to mention, guys, with the output transistors that we added the base resistors to. Oh my god, I forgot what I was about to say. Hold on. Right, I've remembered what I was going to say. The reason why we've taken the heat sinks off and put the base resistor right next to the pin of the transistor is because that's what you want to do. You need to put the resistor as close as you can to the pin. So basically you have a lower impedance on the wire going up to the resistor, and then a higher impedance in that little length of the resistor and base pin. If you do it the other way around, you ruin the damping factor, and basically the wire that goes to the base pin becomes more of an antenna, because you put a resistor in front of the wire at the start, so then the wire has a higher impedance and acts more like an antenna, so it's more susceptible to noise and it screws the damping factor. So I just wanted to point that out. Alright, so I've just been doing a little bit of looking over the boards just one last time to see if there was anything else I wanted to upgrade before I say that, you know, we're basically done. I'll get to these components on the bench in a second. I have to say, I am shocked. These are matched. The transistors that are driving it as a Darlington config, you know, all quite beefy transistors with lower gain, just like this. And then the driver transistor, whatever you want to call it, yeah, driver transistor that drives the Darlingtons, it's a BC107, and for back in the day, I don't think you could find a transistor closer to, say, a BC550 or some other low noise variety transistor with still a decent gain around the region it is. I think these are about 400 or 500. So that being said, I'm not touching the transistors. I am happy with the transistors. After tracing the circuitry out and looking at the data sheets, I was like, wow, okay, good selection. Anyway, I have noticed one more thing that we got to do. Kind of sucks, but it is what it is. I'll just bring this board up to the camera. I don't know if you can see, but these resistors are splitting. You see that? Now, that little bit where there's paint missing on the end of the metal cap, that's not a worry. But when you see a split line basically right around the end of the metal cap and where the carbon film starts, that resistor doesn't have much time left, because now it's exposed to the environment inside, and the heat and the moisture and the minerals and everything, acids and that in the moisture in the air, dust and everything will get in there, corrode the metal to carbon film bond, and you'll end up with a resistor that goes up in value and ends up open, basically, cut a long story short. So I was looking at them and I noticed that they're bigger than these resistors and these 1% ones that they've got, and even the ones that someone else put in there, which I think are 3/4 watt. My 1 watt ones, they still look bigger, right? They're 2 watt resistors. So I powered the thing up. I tried it in all different conditions, and I measured the voltage drop across them, and I forget exactly what it is. One of them's got about 17.5, 18 volts on it. The other one's about 19.5 or 19.8. One of them's a 1.2K, the other one's a 1K. They're running about 1/4 watt. So I got no problems replacing them with 1 watt resistors. I actually have 2 watt resistors. I was going to, but I mean, I powered up and felt them, and they not even that warm, you know, like they're not dissipating much at all. My kitten's just jumped up on the windowsill, which might not sound like a problem to you guys, but this particular window it is, because the blind's basically in front. You know, I'll just show you, it'll make a lot more sense. Yeah, so all that stuff gets knocked off. Anyway, just make sure you turn the camera around again. I hope I didn't have that too far back before. Anyways, so with that being said, I'm going to change these resistors now. I'll go and do it off camera, because otherwise the video's just going to get long with me just talking and doing menial little tasks like changing resistors, and I'm pretty sure everyone's watched me change enough resistors and diodes and stuff. So I'll heat up my desoldering gun, get my soldering iron going, change these 4 resistors. There's 2 1.2Ks and 2 10Ks. And yes, for those that are wondering, I did use my noggin and think about the fact that maybe they used oversized resistors so that they don't get as hot, because they're trying to obtain some level of precision or accuracy. I traced them out. It's not. They're literally just powering Zenas. So yeah. Actually, that being said, might have traced that out wrong. Hold on a minute. Oh no, yeah, that's right. There's 3 2.0 Oh my god. Get out. Right, that's it. Out. There's three 2.2Ks on each channel, and they power those two power these two Xenas. That one powers, I think, that Xena. I can't remember. And then that resistor powers that Xena, and that powers that one. Something like that. When I traced it out, it was something like that anyway. So yeah, those resistors are fine to go in. I am going to leave these in there. I had to think about it, and look, it makes the supply less efficient. You know, I could put higher gain transistors in there, you know, and put lower current, higher gain drivers, or the Darlington's stage, and yeah, I could make it more efficient so it takes less power. But honestly, increasing the gain, I can only see that just adding more noise to the circuit. So I'm just going to leave it the way it is. Yeah, don't know what else to say on that. I'm happy. So without further ado, I'm going to get started on this. I'll pause the video and I'll come back shortly. Alright, so I'm finished with this board. The 1.2K and 1K resistors have been installed. I've also given the whole board a clean up. I don't know if you can tell. That's why you can barely see the Sharpie, but yeah, because it was contaminated as. And also all the carbon I've tried to remove. I don't know if you notice where it was all burnt before, it sort of has like a yellow appearance to it. I used a combination of scrubbing and chemicals, but yeah, I got the fiberglass board back as good as I could get it, and removed any traces of carbon tracking between traces. So that's as good as it's going to get really for an old burnt board. And I also tighten these nuts up because that's the collector, just to make sure, you know, it's got good contact. So anyway, that's this board finished. The only thing that we'll have to do on this board is sorry, I just realised my head could be in the way. When I put this back together and we go to calibrate the panel meters, we might have to adjust both of these pots. Probably just the ones for current, but we'll see. Anyway, so that's done. I've even cleaned up the connectors. This board's just going to go get a quick clean up now. So I'm just going to clean up like I cleaned that one up. But there's nothing else I wanted to do to this other than extra compensation if it's required. And I just wanted to point something out. I know I was saying that these are 22 picofarad and these are 68, and everyone's probably looking at these going, what, these are half the size of these. These are a high voltage rating. That's why they're bigger. They are 22 picofarad and these are 68. Just if anyone spotted that and thought that maybe I misread it or I was wrong or whatever, no, it's just different voltage ratings, that's all. So with that being said, I'm going to go clean the board up, come back, put it all together. I've measured the current across end to end on the pots in there, and there's about 3 milliamps available at about 1.25 volts. Now I don't know if so the thing is this resistor divider, basically one end of the current shunt goes into these two 5.1 ohm resistors that are in parallel, and the other end of it goes off into the input of this op amp, and the other end of the resistive divider is this 620 kilo ohm resistor that goes to the other side of the shunt. I don't know how it's wired up. The pot under like 5k pot with the current that's available, and that it'll be able to source enough current to drive the op amp input. But if it's comparing say the current supplied by the pot against the current supplied by the resistive divider, the 5k pot won't work. It'll throw out the ratio. So I honestly can't be bothered tracing out all the circuitry and trying to work it out, because it goes between two boards through connectors. It's really convoluted and confusing. So it's just easier for me to just swap one pot, desolder 3 wires, solder them on here and see if it works or not, you know. Quite simple. The other thing I'm thinking about doing is across, now this I will have to do a little bit of digging into the circuit to work it out. I'm thinking about putting a small cap, like 1 microfarad to 4.7 microfarad across essentially the wiper and one end of the pot. I've got to work out which end, but what this will do is if ever in the future the wiper gets old and it becomes intermittent, the contact, the voltage and current doesn't just shoot up and fry the circuit you're on straight away. The capacitor will basically hold the voltage that's across the pot as it, you know, is loose and intermittently making contact. Now obviously as it gets worse it will end up being a problem, but hopefully you notice it before it becomes a problem. Without the capacitor you don't notice it until it's a problem. So I might do that too. It also depends if the pot is hooked up in a way that adding capacitance is going to slow down the current reading. It actually might improve it. For example, if the pot's say in the feedback path, or the pot's a resistor, so it lets DC through but it has resistance to it. If you put a capacitor across it, all of a sudden you've got an AC path. So in some circuits it actually improves the function in a power supply in terms of the AC loop. But yeah, I've just got to trace it out. So I'll go clean this up, sort that out, be back in a minute. Oh yeah, one more thing before I go off and clean this up. These wires I said I've got to resolder, and yes, for the keynote I almost pierced the wires by getting it stuck in one of these connectors. It's actually alright, it didn't go through the insulation. But anyways, what I'm thinking of doing is taking the cable under the board up through the hole and then put the wires in so that they can move around quite a bit, and basically it will have a bit of strain relief. So I'm gonna do that for sure. Yeah, so I'll go off and get started on this now. Actually, to be honest with you, I might not do that, and I'll tell you why, because the cable's short and I really can't be buggered cutting all the heat shrink off and reheat shrinking again, risking the heat shrink, moving the pots, having to reset the pots. I might just cut the wires shorter and tack them on the back, say I might just reconnect them exactly how they are, to be honest. Yeah, I think that's going to be my most viable solution without wasting time having to remake up the wires for it. Alright, I'll be back in, well, literally a second for you guys. You know what, I just got a torch and I was just looking at the base of the wire and feeling like how sturdy it feels. There's not one strand snapped yet, and it actually feels quite sturdy, so I'm just going to leave them how they are. This board's probably only going to come in and out maybe once or twice more, so as long as I'm gentle with it from now on, I think it'll be alright. If they snap, I can redo them. Alright, I'll be back in a sec. Alright, so I've cleaned this board up now too. Both sides, as you can see, nice and clean. I'm going to put these two boards together, and here's why. Any calibration I've got to do now, so for the meters, it's just these two pots. I tested my references yesterday afternoon, they're all still bang on. And then if the constant current high limit and the voltage high limit is off, well, the constant current resistor combination, resistive divider, should I say, that goes across the shunt resistor, how do I explain this, sets how much current this op amp sees. It's these resistors here, which obviously I'd be soldering a little pot or something on the back of the board across one of them. So, and the same thing for the constant voltage circuit. Let me just put these two boards together. Beautiful. Right. So the constant voltage circuitry, the resistive divider for that is all of this. So if I needed to trim that, there's actually multiple different ways I could trim the value of that. I could either add resistance or subtract resistance to one of these two resistors. I'll have to trace out to work which one. I could modify the value of this resistor, or I could also stick a resistor across the pot itself. So the boards are done. They're going to stay together now. Got nothing more to do to them. I'm just going to put them off to the back there, and we'll get on with the pots. I'm not going to even bother wasting my time tracing it out and seeing. I've done a few basic measurements and I think it's going to work. So current voltage wise, it's doable with a 5k pot is what I was going to say. My phone just died. Sorry about that, guys. Just quickly, I just want to point out, yes, I've checked the power fuse in it. There's not something stupid like a 5 or 10 amp fuse in it. This is a beautiful old school fuse. Proper silver plated, I'd say aluminium or copper caps. Little brass spring in the end of it. And then it's got a special little alloy ball of solder that's designed to melt at a certain temperature. And then it's got the fuse wire itself. You don't see stuff designed like that these days, I can tell you that now. Oh, and it's a yeah, 1 amp time delay fuse. Cool. Alright, well, I'll start removing the pot. Actually, I'll do it on video. I'm just going to go duck off and get something to eat because I'm absolutely starving and I can't work like this. But I just wanted to grab a couple of things. Sorry. Because this is quite interesting. So far, this is all the stuff that's been removed by me and replaced with better parts in this power supply. Oh, and you can add the 2 big filter cans onto that list too, but I left them in there because I want it to look sort of original from the top when you open it and look inside. I like it, looks cool, you know. I mean, I can't make the big wire wound resistors look original but going to carbon, but just about everything else can make it look pretty original still, you know. But yeah, quite a lot of stuff pulled out of it, hey. Anyways, I'm going to go feed myself and then come back and we'll dig into these constant current set pots. So I got a little bit of bad news. I just spent like, I don't know, half an hour recording more footage, and cut a long story short, basically I ended up well, doing everything that you'll see in what I do, uploaded the footage, but I'm deleting the last 30-40 minutes because it's just bullshit. I got up to the point that I put 1 meg calibration pots, 1 mega ohm calibration pots across the constant voltage pots to set the high limit, and that worked out fine. I then put some 5k multi-turn pots on the constant current and went to trim them with resistive trim pots to trim the ratio, because I'm going from 500 ohm to 5k, and incidentally that did work out perfectly fine on the master channel. Well, it didn't on the slave, and I'm really pissed because I've bought 40 of these all up, and I've had so far over the last couple of years probably about 5 duds. And remember I was mentioning that this pot here, which I just put in, they're all brand new. It feels really loose, but the others feel nice and tight and smooth. This is like loose. It still works, but well, guess what? I put this one in, I turn it on, the bloody voltage on this side's going back up all the way up to like 56 volts. I've gone, what the hell? That can't be possible. It's not like my 10k pot could have turned into a 20k pot like the original problem. So I pulled the boards out, went over every single resistor in the resistor divider networks. Nothing was wrong. And got to the point I started suspecting that there actually was still oscillation and that I needed to do more work, and I just cooked an op amp. And then I worked out that no, look at this. Turn this pot all the way down, right? Only goes down to like 5 ohms. And look at this. That's the other side of it, right? That 2.4k you're seeing? That's not the pot. Look. Sorry. I just realised you guys can't... Shit. Ah, fuck. Man, I'm not having a good night now. Okay. You see that? Half the pot's not even there. I just can't believe it. So what I've done is I've gone through all of them and I found 2 actual nice, tight, good pots, but they're 10k. So that's why there's 2. I'm going to take both of these out, the 2 5k pots, the bad one and the good one, and replace them with these 2 10ks, and then we'll adjust them. Because the thing that happened was what happened when I went from the 500 ohm pot to the 5k pot, I was able to turn the current up way too high. It still works perfectly fine, so I just need to trim it, which is what these are for, to set the height, like the high set point, like what I've done by putting trimmers on the back of the constant voltage pots to set how high you can turn it up. So I can trim it to exactly 30 volts, you know. So each channel can only go between 0 and 30, and I can trim these so it can only go between 0 and 1 amp. Anyways, yeah, I just thought I'd come on and make this little update and add it onto the video that I was just making, because like I said, I just had to delete a lot of footage and I wasn't going to make you guys watch all that just to get no result out of it. So I thought I'd just explain what's happened, and I'll upload this video, and then tomorrow we'll put these last 4 components in, and then we'll calibrate it. By the way, this thing's fully calibratable now, so we've got 4 trimmers to set how high the current can go on each channel, how high the voltage can go on each channel. We've got 4 adjustable references, and we've got adjustable current and voltage for the panel meter, and the same for the other panel meters. So there's 4, 8, 12 points of calibration inside the thing now. Bear in mind, the way this came had no points of calibration. Oh, well, I guess you could calibrate the panel meters, but that's it. Anyways, I'm going to sign off now. I guess I'll see you guys in the next one. Take care. Please like and subscribe. It would mean a lot to me. I'm just trying to get my channel going. I'm a newbie. With that being said, I'll see you guys tomorrow. Bye.